This carport roof in Mossel Bay was severely damaged after winds of over 100 kilometers per hour lifted and destroyed the existing roof sheets. Fortunately, the main support structure was still standing, but once I started inspecting the roof, I found a much bigger problem. The original structure had been built with timber that was simply too small for the span it was carrying, causing the entire front section to sag and bend over time. At that point, it became clear that replacing the roof sheets alone wasn't going to solve the problem. The structure itself needed to be rebuilt and strengthened. Structural problems. The front support beam had been built using two 114 by 38 millimeter timber members, which were expected to carry a span of approximately 6 meters. That size timber is not sufficient for a span of this length, especially when supporting the roof load and dealing with strong coastal winds. The roof rafters were also spaced too far apart, at roughly 1.8 meters between centers. This allowed excessive loading on the structure and contributed to the sagging and movement that had developed over the years. Rebuilding the frame. To correct the problem, I removed the existing front beam and replaced it with a much larger 224 by 50 millimeter beam. This significantly increased the structural strength of the roof and eliminated the excessive flexing that was occurring. One challenge on this project was that I was working alone, and lifting a 224 by 50 beam into position by yourself is not an easy task. To make the installation possible, I built a temporary support bracket. This allowed me to lift one side of the beam, slide it onto the bracket, and then gradually work it into its final position without needing extra hands on site. It's a simple solution, but sometimes a few minutes spent building a jig or support can save hours of frustration later on. Once the new beam was roughly in position, I used a step ladder together with my backy jack to slowly lift the existing structure. I carefully raised the old beam until everything lined up at the correct height. Instead of completely removing the original timber, I secured the new 224 by 50 beam directly to the existing 114 by 38 beam. This allowed me to retain the existing fixings at the wall and support posts while dramatically increasing the strength of the structure. In many cases, people assume that everything has to be demolished and rebuilt from scratch. Sometimes that's true, but in this situation, the original beam wasn't causing a problem because it was damaged. The problem was simply that it wasn't large enough to carry the load by itself. By tying the new beam into the existing beam, I was able to strengthen the structure, save time, reduce unnecessary demolition, and create a much stronger overall assembly. Why the roof failed. When you look at the old roof from a distance, the damage appears to have been caused by the wind alone. But once the roof sheets were removed, it became obvious that the structure had been under stress for quite some time. The front beam had started sagging, and the rafters were spaced too far apart. Every year, the roof would carry its own weight, endure wind pressure, and experience expansion and contraction from changing temperatures. Over time, all of those forces add up. Then one day, a storm comes through with winds exceeding 100 kilometers per hour, and the weak points finally give way. This is why structural framing is so important. The roof sheets are only as strong as the timber structure supporting them. Installing the rafters. With the new beams securely in place, I could start installing the rafters. These rafters transfer the roof load back into the main structure, so spacing is critical. The original roof had large gaps between rafters, which allowed excessive movement and flexing. For the rebuild, I reduced the spacing to approximately 1 meter centers. This creates a much stronger framework and provides far better support for the roofing sheets. As each rafter was installed, the roof became noticeably more rigid and stable. By this stage, the difference between the old structure and the new structure was already obvious. Attention to detail. A lot of people focus only on the final result, but the strength of a roof comes from dozens of small details working together. Correct spacing, proper fixings, adequate beam sizes, strong connections. Every one of those details contributes to the overall performance of the structure. You can install the most expensive roofing sheets on the market, but if the supporting structure is inadequate, you'll eventually run into problems. That's why most of the effort on this project went into strengthening the frame before a single roof sheet was installed. I then installed new rafters using 114 by 38 millimeter timber and reduced the spacing to approximately 1 meter between each rafter. This distributes the load much more evenly across the structure and provides far better support for the roof covering. One thing I wanted to improve on this rebuild was the way the roof structure was supported. On the old carport, the 114 by 50 rafters were simply fixed with nails and a couple of coach screws. That meant the weight of the roof was effectively hanging on those fasteners. For the new structure, I wanted something much stronger. I installed a 38 by 38 timber batten along the back beam and secured it with multiple screws. This creates a solid bearing surface for the rafters to sit on, rather than relying on screws alone. At the front, I reused the existing 114 by 50 member and cut small packing pieces from the new timber, so everything lined up perfectly with the 224 by 50 front beam. Once the main framework was complete, I installed the purlins that support the roof sheets. These were spaced at approximately 800 millimeter centers to provide a strong and stable base for the roofing panels. The result is a much stronger roof structure that is capable of handling wind loads far more effectively than the original installation. For the roof covering, I selected a lightweight 1 millimeter UV-resistant white roof panel. The main purpose of this carport is to protect the vehicles from the harsh coastal environment by reducing direct exposure to rain and sunlight, helping to minimize rust and weather damage. The previous roof used clear panels, which allowed most of the sunlight to pass through. As a result, the vehicles still experienced significant heat buildup and sun exposure underneath the structure. By switching to the white UV-resistant panels, the roof now provides much better shade while still allowing some natural light through. This creates a cooler environment for the vehicles without making the area feel dark and enclosed. Although metal roof sheeting would provide even greater heat reduction, the client was working within a budget. These panels offered a practical and cost-effective solution while still delivering a noticeable improvement over the previous roof. The new roof sheets were installed and secured using roofing screws throughout the roof. The fixing pattern was designed to provide excellent holding strength and prevent the sheets from lifting during strong winds. Every stage of this installation was completed with durability and long-term performance in mind. The final result is a completely rebuilt carport roof that is stronger, straighter, and far more resistant to future storm damage. What started as a simple roof replacement turned into a full structural upgrade, giving the client a roof that should withstand Mossel Bay's harsh weather conditions for many years to come.